Just welcome everybody to the Sheffield IoT Meetup number 7, our second in the summertime series and our fourth event fully online. We missed recording the first 10 minutes of the session, so this is just a little bit of a rerun to introduce you to the first part of the section, which is based around our IoT students that you would have met at our last meetup. Where they are currently involved with a student placement program where they are working on some of the IoT prototypes and code of their own designs, making use of the citywide LoRaWAN network that's been installed in Sheffield. It's been headed up by Dr. Randy Taylor, who's one of the university teachers at the Department of Computer Science, and he's the lead supervisor for this pitching program. And he'll introduce them a little bit later on in the program. But first off, we have Seth, who will be talking about data collection using bicycles. So Seth, if I can pass you over to you.
All right, so thank you, and my name's Seth, and I am looking into how we can use IoT and LoRaWAN technologies in partnership with cycling. So I was led to this because I wanted to work in something that was involved in public and personal health, and also kind of helps out the environment. So that's what led me to really want to do this. And so far, what I've managed to do is, unfortunately, I wanted to have you could track where bikes were going and the data about how fast they were going. So I wanted to design an IoT technology that would allow for track the position of the bicycle and its speed, also the air quality data around that. And unfortunately, I wasn't able to measure air quality data because I could never get my hands on a sensor. And so unfortunately, I was never able to use the air quality sensor, but I was able to map position data and from there get the speed. So I took the data from the Things network and then put it through Node-RED and connected that to InfluxDB and Grafana. So what you're seeing here is a Grafana dashboard. So I've got a speedometer, I've got a speed graph, and I've also got a speed map. So you can see, based on the colors of the dots, how fast they're going at that specific position. And also we've got an ant path trace to see the trace of your actual bike route. And so for next steps, obviously I would like to pair this up with an air quality sensor, but also be really interested in having lots of different cycling data from more than one person cycling, as I believe that this data would be more useful for local councils and for larger projects. And hopefully, given that cities want to have a green rebuild and they want to reduce traffic, hopefully this data could be really interesting and useful for them. And that would really allow my IoT projects to do something good.
That's great. Thanks ever so much, Seth. The next section, we'll come in halfway through, or we'll miss the beginning of Moana's a presentation on indoor and outdoor air quality monitoring. So that'll be just coming up right now.
In order to compare indoor and outdoor air quality, this data needed to be separated. So I had to redesign the node-RED layout, which is the top picture on the slide. I chose to incorporate a switch node that moved the data to a different influx table based on the device ID. This separated the data and allowed for more accurate analysis. I then created a Grafana dashboard to analyse the data, which is the bottom left picture. I chose to look at humidity and gas resistance, as a higher gas resistance indicates a better air quality. I found that the two indoor air quality sensors had a higher gas resistance than the ones outside, which would suggest that the pollution outside isn't necessarily being flushed through the building. In terms of next steps, I'd like to calculate the indoor air quality index to draw a more accurate observation from the data. I also intend to set up email notifications on Grafana so that when the gas resistance drops below a certain level inside the building, they'll know to improve ventilation in that particular room. Thank you for listening, and please don't hesitate to ask any questions.
Cool, thanks for that, Anna. Yeah, if anyone's got any questions you want to stick in the chat, I think we'll try and avoid checking Alex's speeding ticket history. But Seth, maybe did you do any kind of analytics at all on the data? Can you tell us anything interesting about Alex? Seth, he's vanished. I'll hand back to Mark anyway in the meantime.
Well,
Oh,
just
sorry,
before
I cut out my Wi-Fi. Went funny for a second. I'm sorry, I didn't hear whatever was said.
Ramsey, you have a
So
question for Seth? Ramsey, can you hear me? You had a question for Seth, who's now online. Can you see him?
Yeah, sorry. Yeah, so the question in the chat was about whether Alex was speeding or not, and I don't think we want to get into that one. But I wondered if Seth had done any kind of analytics on the data that he saw. I know it was a joke, but did Alex's bike pass any horrible black spots of death or anything interesting?
No. Well, it was interesting because I counted data. It was a bit of a botched method to try and calculate the speed because I had a Node-RED trigger like a Python script every time it would come through, and then that would calculate the speed data. And it was interesting because I assumed initially that all the message was sent out every 10 seconds. So one time I think Alex was moving about above 70 miles per hour on his bike. And then I actually found out that there was variation in times that were sent, and then that gave a more usual speed.
A question from me for Ramsey is what's the next step for the project? So you have these great ideas with these students, certainly for the first three great projects. What's the next step for them? Will they ever get their kits to be able to actually sort of develop this further? What's the sort of thought process, Ramsey?
Yeah, it is a good question. I mean, as I say, very much when we put the proposal together, what we wanted, not that we didn't want them to produce brilliant projects, but what we wanted out of it was what they've very much given us, which is 10 weeks of people doing the kind of painful research of how do you make these things work in the first place. And I think they've all managed to get interesting stuff to work in the first place. Lots of them now, if you wanted to take these on, would need that kind of next step of how do we turn this into a viable product and how do we make something useful. Some of the students may want to do that on their own time, and we're happy to help them with that. I know you guys at Ioetec want to see if you can get them involved in some of your projects going forwards. I might have another project going forwards with some guys over in Barnsley as well. So there's various projects going forward we hope the students will be interested in. But yeah, I mean, very much the stuff they've done is going to be on GitHub for anyone who wants to kind of take on their idea and advance them.
Okay, that's great. All right, thanks for that, Ramsey. If we move on, perfect timing to our first keynote speaker, Professor Fabio Silvanga. Are you online, sir?
Fabio is online. Oh, there we go.
Here we go. Fabio, welcome. Thank you for joining us today. I think you're on your mute. On mute button.
Yeah, okay. Okay, can you hear me now?
Welcome, Professor. Hand over to you.
Okay, so I'm just waiting for my file to upload, but I will probably share my screen otherwise. Let me just check one thing. Yeah, it's still going very, very slowly. But anyway, I'll share my screen then so that it will be easier to see what I'm doing. So can you tell me if you are seeing my screen now?
Okay, yeah, we've got that to work safely.
Okay,
good to go.
So, thank you. So, as I said, I'm Fabio Cirovegna. I'm Professor of Pervasive Technologies in the Department of Computer Science of the University of Sheffield, but I'm also CEO of Equoral Ltd, that is a startup company that we have created recently. I'll mention first of all who we are, and then I'll mention more about the technology you're more interested. So Equoral was originally created in 2007 as a university spin-out called Knowledge Now. They specialize in a number of areas of knowledge management, but we have effectively recreated it this year in February 2020 as a company that does tracking technologies, working at scale, mostly tracking indoors and outdoors. We have done this by acquiring an IP that was developed by the University of Sheffield, by my group at the University of Sheffield, that has different applications. So, but we are also working in collaboration with a company called Azun, that is a global technology consultancy company operating in Europe, in Australia, and in the US for commercializing this technology I'm going to present. It's all about going back to work after the lockdown. This is something we are trying to do painfully. The situation we are in is clearly unprecedented, and there is a concrete risk for a second wave. Some countries don't have a second wave simply because they never left the first one, but others are constantly coming into them. Spain is one, for example. So there is a constant balance to be kept between going back to normalcy in the workplace. That means going back and work, while at the same time keeping the contagion or the risk of contagion very low. The fundamental task for any business or organization who wants to go back to work is to de-risk the phase, and de-risking is complex because the entire operation is of course a risking lives of people. So what we did back in April, we started asking ourselves about how we could ensure, first of all, the return of our employees, but also to protect the employees that were at risk. And also we asked ourselves how can we feel safe when we are at work? So these are the initial questions. And so we applied with Innovate UK for a grant for COVID-related grant, and they felt it was a good idea, the solution we came up with. So we felt, well, you're safe in a workplace if the workplace is clean, first of all. If you are fully informed of any risk that may be happening inside the company or outside the organization, if you feel protected because you have the protective equipment, and if you are compliant. If the organization is compliant with any kind of regulations, but also to demonstrate that they are compliant legally. And also, you are safe if you keep a safe distance from others. So if you don't get too close to others, but also if your shifts and your work requirements don't put you in close proximity with others. These are two different things. One thing is me not paying attention. The other one is, well, there is no other way that I can work except if I go close to others. So our vision was to have a simple solution. It's a digital solution that supports business and organizations across the world. You're going through Azun outside the UK, in order to support workers keeping the right level of social distancing while allowing direct and clear information and all the things they just said. The idea is to help companies organizing the work so that they have comply with any kind of regulations. And regulations change from country to country, so they are quite complex. And also to identify immediately any potential or real outbreak, because this is time is extremely important in this case. So the features that we have created a system now that enables automated proximity detection using mobile phones. There are lots of technologies that use other types of, for example, IoT devices that you have to buy and may cost 20 or 30 pounds. But this is not scalable in our view. What you have to do, you have to use the device that people have. And what do? We are able to get communication as well. So first of all, you detect proximity, but also you can receive any kind of communication from the organization, and so that you can make sure that people know what they need to know about the risk, about the potential threat for today, and so on. And also to support the company to plan the shifts and the organizational work. And at that point, we provide a dashboard where the risk metrics are provided to the company so that they can detect the things like vulnerability, distancing violation, overcrowding, and so on. So, well, the solution has an employer dashboard and an employee mobile dashboard. The dashboard for the employee enables create the groups of people. They are supposed to work together. It's very important that people work in close communities so that if any outbreak comes in, they do not spread over to the entire company. You want to identify the areas of risk that are locations because people are overcrowded, but also the kind of limitations. You know that in a specific room you cannot have more than 2 people, so you upload a map and then you allocate the number of people for different areas. And also then there is the PPE equipment. People feel safe if they have the right equipment, but also they must be safe because they must be able to get the equipment that they ask. And then also from the dashboard, you can see people are too close together so that you can optimize whatever you are doing in terms of organization, or you can tell people, look, you tend to be too close to people. The employee, on the other hand, can get all the safety-related messages that are relevant to them. They can check in areas and check out areas by scanning QR codes that are put in the rooms. They can request PPE equipment, but especially the app beeps if they come too close to other people. So that's the real point. The real point is that you keep safe because you are reminded if you come too close to people. And any kind of violation of the social distancing is recorded in an anonymous way. So at the end, you have your own count saying, well, you had this, say, 10 times today you were close to people. But also the employer knows that. They will not know who you have met, but they will know that you have violated a number of times. So this is all done through Bluetooth detection. We have a unique IP that we have developed to do that. It's all built on our mobile tracking experience that we have used with 1 million people across the UK. It works on iOS and Android, and it works on continuous advertising and tracking in the background at sub-second level. So basically, if you come too close to a person, within 15 seconds, the phone will start beeping loudly. The detection area changes, so you can choose it yourself, because either the regulation in different country can be different, or you may feel unsafe. If the regulation is 1 meter, you want to put it to 2 meters, then this will beep as soon as you enter. Someone else enters at 2 meters. And it's privacy preserving because it changes every 15 minutes, it changes the ID, so nobody can track you. This is one of the requirements. Then I said the company can decide to very quickly and very easily to define different areas in the company buildings where you can go and you can scan a QR code to say that you have entered or you have exited. We use also beacons to do that, to do it automatically, but most of the customers actually prefer the QR code. QR codes can be existing, or we provide the facility to create QR codes. There are, however, not just a matter of violation of distance. You can also have overcrowding. So for this, we have, for the communal areas, we can provide some relays that will detect the number of people, the excessive number of people in a specific area, and they can be done also on the fly, so you can move them around if it is necessary. Well, this is the collision record I mentioned before. This is the dashboard. Well, we're not going to details. As you probably see, the dashboard is in Italian because this is a multi-language product, and it is the first commercialization happens in Italy. I said these are instead the messages that the employer can send. They can require acknowledgement of I've read it, but also I've read it and I will act on it. And these are quite important for showing regulations. Then this is a request for PPE provision. So if you need any kind of mask or any kind of visor or whatever you need, this is recorded formally, and you will receive a formal answer within some hours. And this is again to show compliance. So on the one hand, the person feels safer because he receives. On the other hand, the employer can show compliance to whatever is necessary for either the regulation or simply because of the agreement with the unions. The advanced part is about supporting the scheduling of the shifts, so the organization of work. This is where this is the next step. We haven't implemented it, but we are applying artificial intelligence to optimize based on the parameters I mentioned before. So number of violations and creation of enclaves so that the virus doesn't spread and so on. That's pretty much it. So the product is now about to be launched. It's ready, and we are, well, I'm happy to answer any question. Unfortunately, I was using my application, so I haven't seen any of these any of the questions if they come in. So I probably have to go and read.
So Fabio, Mark here, you're saying you're about ready to launch the product. What is the kind of typical installation you'd hope to perform, and what sort of size, in what kind of environment, and what would be the kind of costs that would be involved for a business taking something like this on?
So the product is very flexible in the sense that it can adapt to very small organizations, very large organizations. The small organization will have, say, a server that is in the cloud provided by us. The features can be selected, so you may not want the secure messaging because you have, or you may not want to have the PPE request and so on. So the basic one is the social distancing one. And that depends on the number of users. So we have up to 25 users, up to 250 users, up to 2,500 users, and so on. The price really depends on all these factors. So it's very difficult to give a ballpark figure. But the idea is that it really is based on the size of the company. So we are not asking for 100,000. From small companies and the other way around. If you have 3,000 employees, of course, it changes. But the idea is to be low cost so that it is definitely worth having it rather than not having it.
And so for instance, in small factories, for instance, where an operator or owner of a manufacturing base wants to be able to ensure that he's compliant and with health and safety, etc. So it would be affordable then to somebody with a small factory, as an example, or a small operation.
Yeah, the idea is to start from size like 5 users,
right?
So 5 people. So really small, and to scale up. And the reason is that very often it's not necessarily the large organization that will have problems, but they are the smaller organizations where the health and safety is not necessarily well established as a process.
Quite, and it's easy to scale up from that point, then, is it? So once you've established your initial foundation installation, from that point on, it could be scaled up quite quickly.
Yes, you can, for example, take a situation where you want to establish, you have a reasonably, say, a medium-sized building, and you want to enter. Initially, you can immediately start with the messaging and with the social distancing, but then you may slowly create the different areas. So you upload maps. You say, well, this map in this area you can have a maximum of 5 people from now on. They have to check in and check out. They enter. So this is all scale up, but there is a core that can be launched, say, tomorrow morning, as a way of saying. Then different customers, of course, can ask for different types of customization, and then, of course, that may take a bit of time. But we have all the infrastructure to develop that.
Right. Okay. Question from Phil: does it work cross-platform? It hasn't had the problems that the NHS app has, for instance. So it works on Apple, works on Android phones.
That is correct. It works for Apple and Android. What you can do for the social distancing is that, I said before, you select first of all the distance, then you have to what you do, you have to calibrate your phone using another phone. So basically, you put it, say, 1 meter or 2 meters, whatever distance you want, with another phone to make sure that it records the correct distance. And then it will work both in the background and in the foreground. So even if the screen is off, we'll still be able to do. That is really where our knowledge of tracking comes into place, because I know that the NHS has made big mistakes in trying to convince them to listen to the fact that they were going the wrong direction, but they wouldn't listen.
Yeah, that's brilliant. Well, Fabio, thanks ever so much. Really interesting, and I wish you well for the launch of the product. If anybody has any further questions, just put it in the chat, and I'm sure that we'll get Fabio to get back to you. Thanks very much for your time today.
Thank you.
That's great. Okay, so we're going to our second of the sections for the students. So Ramsey, hopefully you're around still.
I'm here as long as you can hear me.
Yeah, I can hear you fine.
Still on.
Over to you.
Okay. So I think our next bunch of three are all kind of in manufacturing and industry settings, although our first pair, actually, they couldn't get to the factory because of COVID. They've ended up doing some interesting security angles on some of this stuff. Nathan, are you there to do this first presentation? Have we got a Nathan? I think it's Nathan's turn. Nathan and Harrison.
I didn't unmute myself. There you go. I'm here. Hi. Sorry. Hi everyone. I'm Nathan. I'm a third-year computer science student. And I worked with Harrison, who presented last time you were here, who's also a third-year computer science student. As Ramsey mentioned, our original plan was to try and work with the AMRC to focus on legacy equipment, and if we could do predictive maintenance on that by using certain sensors to measure stuff like vibrations and other accelerometer data. There's also a project that's already done that at the AMRC, and we ended up speaking to Mike about that and building on from that, and that's how we came to where we got in the end. We had a lot of logistical issues. We couldn't get some hardware because of COVID-related stuff, and I live in an unLoRaWAN area, so that became quite frustrating to deal with. So we ended up just sort of focusing on more atomic problems, like building backends and trying to like build correct like architecture systems for how we would like the project to go forward if we were to use it. So most of our code is just backend stuff like node servers and setting up like databases and stuff like that. And one of the big problems that we came across that was we tried to really investigate security, because Mike had a conversation with us about how he had a project already at AMRC where there were security issues because they were concerned about letting their firewall down, for example, about certain stuff. So we started to do some real investigation into that. And basically what we came to was it's really difficult to find information about LoRaWAN security. I'm no expert. I've done a couple of security modules and stuff like that, and I know basics for how to make semi-secure apps and stuff like. But I couldn't find proper good information about it. They have one page on their website devoted to the security that just says there's end-to-end 128-bit encryption. But for example, if you want to use MQTT, the default settings just aren't secure. They're sending to a public port, not the closed port, and that isn't documented anywhere online. And we only found that out because Mike told us. Like that wasn't something we discovered. So basically, our takeaway, and we got a little document looking at some of this, is that the documentation and understanding and knowledge base around LoRa security, especially if you want to work like sort of with professional data like AMRC who don't want to lose that data, there's really not a lot of stuff out there. And I know that kind of sounds like a bit of a boring answer, like me saying there's not enough information, but currently the way things are, it just says if you set this up correctly, you'll be okay. And I don't feel that's an appropriate way for something that people are meant to be using publicly to suggest that if you just do it right, you'll be fine, when there's no information on exactly how to do it right. So yeah, that's basically what we have to say on the matter. There's some security worries there that aren't clarified either way, really.
Cool. Thanks for that, Nathan. There's some questions, but we'll come back once we've done the block of 3, because otherwise this, of course, will drag on epically. Next up in this block, I think, is Ammar. Are you on there?
Yes. Can you hear me?
There he is. Hi.
Yeah.
Stuff as well. He's running a slide. Someone can. There we go.
Yes. So I'm Ammar, and my project is on industrial energy monitoring. So I'm a final year student in mechanical engineering, and the main reason I was interested in this opportunity to start with was the potential impact that it had on helping transition the energy system towards a share of renewables, since the main issue it had with the introduction of solar or wind power, for example, was the intermittency in their generation, which was negatively affecting their reliability. And so for this project, I focused on the steel industry, mostly because of the suggestion of one of the mentors on this project, Alex from Tinsley Bridge. And the advantage that the steel industry happened to have in that case was that it was relatively high energy consuming within the manufacturing sector. So there was a lot of impact towards decarbonizing it. And so per the IEA, the best way going forward to reduce the CO2 emissions of that sector was through an improvement in its efficiency. And so my proposal was to create a framework for a demand response energy management system for a case study of a steel manufacturer having its own local solar generation facility. So in the last meetup, I went through the latter part of the framework with arranging the data into a database and presenting on a dashboard. And because of the challenges we had in getting actual sensors, I mostly relied on historic data for power consumption and solar generation. And finally, for a brief cost analysis, I got some data for the prices of buying and selling power from the grid and arranged it into the dashboard you can see in the bottom right. So the main takeaway from that dashboard was that it could be used by technicians within the factory to try and understand when during the day can they perhaps change their consumption patterns to match with the solar trend to increase the revenue from the solar farm and reduce things like payback time, for example. And then after that, to get some experience on the technical side of things, I set up with the help of Stephen Jubb who was a mentor on this project, to set up virtually a gateway and node on the Things network, and to try and get some data from an industrial grade sensor. I used an air quality monitor. So the main motivation for that was that so I can try and understand the challenges which might be in dealing with the data from that kind of sensor, which might be similar to what an energy monitoring sensor would be. And so to manipulate that data and to make it in a readable format for InfluxDB to be stored on a database, I use Node-RED, and then eventually visualized it on a dashboard as well. So I guess the next steps going forward would be to actually implement this with some live sensors to get live data, and perhaps the addition of some energy storage means, which would definitely shift the cost analysis for this. But yeah, that's it. Thank you.
Cool, thanks for that. Yeah, if anyone's got questions for Ammar, you want to stick those in the chat, because our third one now should be Ahmed, if he's around.
Yes, hello, can you hear me?
Cool, go for it.
Yes, hello, I'm Ahmed. I'm a third-year electronic engineering student at the University of Sheffield, and my project area is wireless temperature monitoring in industrial applications. So with the help of Alex Kelly from Tinsley Bridge, I've been trying to build a LoRaWAN node, which can be used to monitor the temperature in enclosures, quench tanks, and different machinery throughout their site at Tinsley Bridge. So this would mainly help with saving maintenance cost and time and detecting faults in those pieces of equipment. I've tried building this with a few different types of sensors, and I've ended up using the BME280 sensor, which gives more accurate readings, longer range, and gives readings for temperature, pressure, and humidity, which can then help allow the use of this in other applications, such as in warehouses, monitoring the food safety in fridges and other storage areas, and in agriculture. So I've been able to build a LoRaWAN node using this Adafruit board, and it pushes the BME sensor data to the Things network every 10 minutes to a nearby gateway. The MQTT broker runs a Python script and retrieves the sensor data from the Things network and stores it in an InfluxDB server, and then displayed on a dashboard created on Grafana. Before I was in range of a gateway, I was using the data that Steve helped set up, and I was able to retrieve his data and just display that on the dashboard. And this board has a JST connector, so it can easily be connected to a battery. And when I put it in sleep mode, the transmissions dropped the current from about 13 milliamps to 300 microamps, which is a big difference. There are a few different settings for how you would put the board to sleep, and the lowest it would go is 300 microamps due to the 80 mega processor it has on board. So this would save a great deal of battery life, and hopefully just increase the battery life of these end nodes. Thank you. That's all.
Cool, thanks for that. I can see Nathan's on the chat because there's been a number of security questions. I'll let him answer the questions, but I think some of the questions kind of get to the point. So someone's asking, I thought over the air on TTN is as secure as SSL. And of course, the encryption involved is just as secure, but that's only part of the story, isn't it, Nathan?
Yeah. I'm not questioning whether the encryption is unsecure and breakable. I'd probably say it definitely is completely fine. The main problem I have is that there's no documentation for if it is secure or not and how to implement it securely. Their official website should give more detail and explanation than 2 paragraphs. I don't know about OTAA. All our research was into MQTT. And Alex, quickly, the port is 8883, the secure one, which is encrypted for MQTT.
I don't know whether Alex is asking the port number or what the heck are you talking about secure ports, because this I think,
yeah,
if I've understood this as well as you have, this gets to the point. The over-the-air encryption sets the encryption between your IoT device and the network, and that can be wonderfully bomb-proof. But if the network then sticks it on an open and unsecure port on a web server, who cares? My understanding of parts of the things you were having with MQTT, isn't it?
Yeah, I want to, just before I have anything technical. Yeah, I just want to say we've only been looking at this for about a week and a half, and I'm not a security expert, so I don't. If anyone quotes me, I'm wrong here.
My talk is floating around to explain why this is wrong, but yeah, it's very much a case. Each of the parts is secure, but there's nothing telling you how to set the things up together in a way that's entirely secure overall. Because of course it's irrelevant if it's beautifully securely transmitted to Germany and then published on an open web page.
Yeah, that's exactly right. I'd agree with that completely, Ramsey.
Yeah, so I mean, these guys are sort of finishing up and writing reports, but yeah, it's as much identifying that we're not saying the encryption's broken. We're saying the encryption's brilliant, but who cares if the overall system isn't set up in a secure way? I think that's fair. Does that answer that answers those questions? Mark, Davis, if you want to take over, I don't know if I've missed a question anywhere.
No, you've got them all. I'm sure Mike at the end, if there's any comments, Mike will be able to pass them on at the end of his talk. So yeah, there you go. Thanks, Mike. Okay, thanks for that, guys. Really interesting. It's what I'm finding fascinating about these projects is how much they've achieved in the last month from their presentations back at the end of July. So it's good to see, despite all the challenges and the hurdles they face, that they're actually managing to get something out of this. One of the questions a bit later on maybe you can answer is if you have, all you guys, the students are getting this data out from these sensors, have there been any significant discoveries that you have found during your data collection? That question has been asked. So any significant insights into the data you're being collected? So I'll leave that to you a little bit later. Okay, so moving on to our next guest, we've got Dr. Martin Hyatt. He's at the University of Sheffield, and he's been managing an implementation of the Diamond pilot plant industry 4 demonstrator. Try and say that after a few glasses of wine, which is a research-led teaching facility in the area of the process engineering that makes use of IoT and digital twin simulation technologies. I'll let you explain more. Dr. Martin Hyatt, over to you, sir. Martin, are you there? Hopefully not on mute.
No, it's okay. I've got it now. Okay, now you can hear me.
Fantastic.
Okay, yeah. So based within the Diamond and in the materials, biological, and chemical engineering theme, and the lab that I'm going to talk about is based in one corner of the Diamond on the Brook Street, opposite the St George's lecture theatre. So you might have walked past and you might have seen all the equipment in there, but there'll be some pictures I'll be showing you later. So here we go. So go to the next slide, hopefully. Okay, so so this is it. What you can see through the window is on the right-hand side, but the digital twin and the IoT device that we're building actually constitutes 2 other pieces of equipment, one of them being a continuous crystallizer on the left-hand side, and that's a device that we can use to turn a saturated solution of a active pharmaceutical ingredient, if required, into a particular product size of powder, and then that is then moved on to something called a filter dryer, which is the middle picture, and this active ingredient can then be dried down into a powder. And if my mouse works, I'm not sure if you can see that, but then that gets fed into this area of the pilot plant, where it is mixed with water in an area here in a twin screw granulator, gets dried, gets mushed a bit more in this device here, and then ultimately ends up here at the far left-hand corner where these 2 chaps are, and gets turned into tablets. So that's the process that we've got in the Diamond. There's a little extra that I haven't shown you, which is basically the biofermenter part, which is where the active ingredient would be made, and that would be upstream of all the 3 pieces of equipment we see here. So one of the sort of the challenges that face industry at the moment is that at the moment drug production is a batch process, and so with this type of equipment we can actually go to a continuous process, but that obviously has a lot of issues in terms of quality and robustness of the processing. And so this is where digital technologies can come in hand, where we can monitor it. And then obviously, if we go to the next slide, hopefully we'll have that there. If we're going to go down the route of monitoring the process, which is actually driven by the FDA and something called process analytical technology. And that is where we have sensors attached to the device. So, a bit like the fitting of sensors to legacy equipment, we've effectively done the same. And so that will help the production keep to specification. And also in terms of the university, because the space is quite limited, we can get a lot more students interacting with the equipment through a virtual environment. And also they also have access to the data. So that's the whole point of going to a digital solution, or going digital, as I've said. One of the sort of the key components of this is something called advanced process control, and this is what the contractor Perceptive Engineering has done for us. and they're a contractor that is helping us, along with Siemens and GEA, who make the pilot plant, to make this basically into an IoT device. And what advanced process control does is it monitors the instrument, so you can get a real-time visualization of the data, or you can then do something called model predictive control, and that's basically where you can monitor the system, have your model, and then you can change something in the system and forward wind digitally to see what the outcome is. And of course, that's quite important in production, but it also is quite good in research and experimentation, because you can see the effect of what would happen 2 hours downstream, particularly in a continuous process, immediately or within about 5 minutes. So that's where the advantage comes in. And so here on the top, we've got an image of a PAT device, a process analytical technology device, and this one, it just measures the level of a fluid in the system. Now, the other component of our digital system is the digital twin, and here we're working with a software package called PSE, which is now actually owned by Siemens. And you can basically build a virtual plant, and I've got a sort of a screen capture of an example of that kind of software, and you can totally model with algorithm digitally what is actually happening in the actual hardware on the shop floor. So that really has the great advantage that you can then now play with a virtual model, and rather than consuming a lot of material experimenting on the real machine, you can actually do it on the digital twin. So, for example, if you were to do an hour's worth of experiment on the physical plant, that would consume 25 kilos of material. And if it's going to come to nothing, that's quite a disadvantage. And this is particularly so with industry, because what they don't want to do is use their production facilities to test and do R&D. But also, they don't want you to start mucking around with a very finely tuned system that's used for producing a chemical or product that they want to sell in the long run. So, so not only is it sort of valuable to teaching and being able to play on a digital twin, so you can break it without actually causing too much problem, downstream problem. The companies can also, pharmaceutical companies can also test new production processes in the digital twin before they actually implement it on one of their systems. So how do we build an IoT device? So maybe it was a bit of a misnomer, but I called the presentation digitisation of a pharmaceutical line. But obviously the line is very digital already. It's computer controlled, but the issue was getting access to the data. And that's where Perceptive Engineer comes in, and they managed to, well, they've helped us actually develop the system. So the crux of the system is based on a piece of software called PharmaMV, which is made by Perceptive Engineering, and that basically is hooked or integrated into our systems. So that could be the crystallizer, the filter dryer, or the tableting line. And so that's a way that we can access through the human machine interface, or from the PLCs, the programmable logic controllers, the information that's coming out of the machine, so we can see when valves open, close, torque speeds, revolution per minute of motors, or whatever it happens to be. The other aspect is that this software also connects to the process analytical technology devices, so that can measure, at the moment on the pilot plant, we can measure moisture at the moment, and that's the only thing. And obviously in the future we'd like to develop that further. In the crystallizer, because it's a crystallization thing, that's looking at temperature, and the filter dryer again is looking at moisture. So with the PharmaMV can interrogate the actual infrastructure, the machines themselves, and so that could be the programmable logic controllers or the PAT devices, or it can actually do the same to the digital twin. So the interface to both these, the digital version and the actual version, is the same. And then from the next step from that is actually to generate, in step 3, are the desktop visualization controls. So that's sort of a typical example. So you can see step changes below in the bottom right in the green, and then you can see the effect on the process on above that. The next step was then to get this system integrated with MindSphere, which the university works with Siemens. And so here we have an edge device, and this is what connects to the computer systems within the control room that are receiving all the information either from the digital twin or the actual infrastructure, and then it then puts this data out into the internet. And then from there, everyone can have access to it and play around with either of the devices. So I've got a quick sort of diagram of what we've actually done. So the areas that are highlighted in the red boxes are what we have added to the hardware infrastructure that was pre-existing, which is all the green stuff. So that was bought about 10 years ago, the pilot plant. No, it's 10 years old. It was bought about 3 years ago and installed. And so effectively, we've been retrofitting it to make it an IoT device. So, for example, we've got the Pharma MV software that can talk to the digital twin or the infrastructure, and then we can then store the data on a SQL server and then squirt it out through to the internet via the Mind Connect box. And then students can then access through the laptop, through the Sheffield IT network. And we also have then dongles that they could then plug into these laptops and effectively get the same experience of using Pharma MV to monitor what the data looks like coming off the machine in real time. One of the other little advantages we've done is we've got a Wi-Fi router, so we can broadcast the data locally, and then students can pick that information up either from a client on the shop floor or through their mobile phones once things like apps have been designed for it, and there's plenty of those about. So in summary, that's my last slide, but in summary, the kind of things that we're really hoping to do with this kind of technology in the future as an IoT device is that we'll be able to teach remotely using it, and that's obviously very pertinent at the moment because of COVID. But it's also good if we're, once we get back to lectures, because we can see the actual instrument in operation digitally being through the MindSphere as the data pours out from it. Or you could do a whole lecture theatre experimentation on the digital twin and change dials and knobs and see what the output results are. So that's really quite important. The other thing for industry is that this technology will help go from batch to continuous production, which is quite important because then it basically speeds up production and reduces cost. And then with things like model predictive control and the monitoring that you can do in real time and not actually need to be on site, then you can determine whether your asset is performing and whether your drug is within specification. And that's really, really important for companies, because as soon as a batch goes out of specification, that whole batch has to be written off, regardless if that was only for a few seconds. And obviously that is much more important when you go to continuous production, because of course, whatever that particular run was doing is going to have to be basically thrown away. So in the future, what we would like to do is we would like to incorporate some machine learning into it. Obviously, we would like to put some more analytical devices on it. So we're looking into conductivity, pH meters and things like that. And then one of the other things we want to do is enhance the performance of the digital twin. What I've glossed over was the fact that there are only certain aspects of it that we can write to, and so we don't have full control of the equipment. So we can read all the machine, but we can't write to it. So we don't actually have full control of it through a digital interface. And obviously that would be something we would like to go to in the future. So that's a technical problem, but not insurmountable, as all we have to do is throw some money. So that's me for it.
That's great. Thank you ever so much, Martin. That's certainly one very large IoT device, completely at the opposite end of the scales that Ioetec are used to dealing with. A couple of questions for you around the digital twin. First question is how you define, from beyond Songless, is how do you define digital twin? What's the difference of digital twin against simulation?
So a digital twin is based on algorithms and it's modeled. So it behaves like a complete replica of the instrument. So it's not a simulation. It'll react differently to inputs that you put in. So it should be, depending on the modeling, indistinguishable from the real-time infrastructure. So it's not simulating. So, for example, Pharma MV, when it interacts with the digital twin, can't actually tell the difference if it's working with a digital twin or the real equipment. So the feedback loops and everything is exactly the same, and it's responsive to what to the actual local environment. So you can throw in faults, or you can artificially break bits and see what happens, or increase too much active ingredient, and then the machine should compensate for that, or the digital. Yeah. I hope that answers the question. Okay, and a further question then, are you using a particular digital twin platform, or are you producing your own? So at the moment, it's modelled on something called a suite of software produced by PSE called GPROMS Product Formulate. So that's where the algorithm is. Hopefully in the future we'll be developing our own models, and that would be because we would need to refine the modelling. The digital twin model that we need to, that we'll be trying to develop. So that will be further down the line, along with our machine learning aspirations as well, and better control of the system. Fascinating. That's great. Thank you so much, Martin. The one thing I love about hosting this is that I learn something every time, every single presentation, and it's fascinating. I really appreciate it, and maybe once you get onto the ML, we'll learn a little bit more when you can come back again and visit us. Absolutely, no problem. Thank you so much. Okay, we're going to go over to the last of the three IoT interns, and we're handing back over to Ramsey.
Hiya. Yeah, so I mean, last but by no means least, it's just the three that happen to have scheduled till the end. Have we got Onyeka on there somewhere? And has someone got the slides? Magical slides. Have we got an Onyeka?
Yeah, Ramsey, I'm here.
There he is. There you go. Crack on, mate.
Yeah. My project was in collaboration with Tinsley Bridge and my friend Kennedy DK. So we designed an RFID tag reader as a LoRaWAN application. This tag reader basically scans a tag and sends this information to a LoRaWAN application. Components we used an Arduino Mega, the tag reader, then we used a LoRa shield rather than the things we discussed about in the last presentation, then the RFID tags. This application has a lot of in the industry, as it can be used for attendance monitoring, alarm systems, machine security, and general warehouse accountability. Attendance monitoring in terms of you can get when your employees clock in and clock out. In terms of the challenges we had working on this project, firstly, we had issues with the interface between the LoRa shield and the Arduino, because the interface was a bit different. So we ended up using an Arduino Mega. We also had issues with the format of the messages we're sending through the Things network, because the type of messages you have to send have to have a smaller packet, because you have the fair use policy and you don't want to exceed the amount of time you spend on a node. So at the end of the project, we're able to send this information, as you can see, to the application registered on the Things console. And further improving it, we plan to make a Grafana or Node-RED dashboard to be able to register how many times a particular employee clocks in and clocks out, and also use OTAA rather than ABP, because we use ABP and sometimes the information does not get sent. So we believe OTAA will be more secure, and we'll be able to keep the employees' data secure and be able to send it at the right times. That's all from me. Thank you.
Cool, thanks for that. Robert, are you on there somewhere?
Yes, I am. Thank you.
Who's got the slides? There we go. Cheers.
Here you go. Thanks. So I came at so last time I was doing the angle I was going for was for waste collection, smart buildings and smart cities. I thought that by collecting data like things like bin level and movement of people, you could optimize the times when you would do that. And what I wanted to do, because at the time I was just sending data from wired sensors, and what I wanted to do was I wanted to add a things network connection to the network using LoRa, of course. So in the weeks after the last IoT meetup, I started to do that, and eventually what I wound up with was a sensor node connected to the things network running a script that that I could make it do certain things, like it could send a message every time it detected motion, so it could be triggered on an event. I could have it triggered. I could have it send messages periodically, so it could detect the number of motion events within a certain window and then send that. You can do things like because it was connected to an ultrasonic sensor, so it was actually measuring distance. You could do things like detect what level the bins are at, and so of course you can do things. You can do the periodic and the on event transmissions to do with that as well. You could have it such that you send a message when the bins get to 25, 50, and 70%. 75% full, or you can have it sending out periodically every hour or so, that sort of thing. But then having to deal with this, because I had this Wi-Fi system and also the LoRa thing. So I thought, it was really a matter of integrating the two. It was what I've been doing over the last few weeks, and I realized that that's not just useful for voice collection. I read a white paper recently by the very company that makes these the specific chip on the development board that I'm using, and they're saying that in all of these European cities they've put out, they've been using sensors, all of these wireless LoRa sensors, mind. They're doing things like desk sensors, presence sensing, for the end of optimizing. It was occupancy. So in the Diamond, or really any kind of co-working space or office building, there'll be a lot of no-shows. They found that on average it was about 65% occupancy, and they wanted to get it up to 75. So that was another angle that I considered for the work that I've been doing. And lastly, just an idea that I had, it goes far beyond what I've been able to do over the last few weeks, is implications for contact tracing, because my understanding of how a contact tracing app would work is that it could be done anonymously, and if you can extract that data or some other kind of data over Wi-Fi, and then also be able to communicate via the Things network, you can do things like see which people have been in which buildings, and buildings can get alerts if someone who's been diagnosed with COVID has ever been in that building. That's all from me. Thank you.
Cool. Thanks for that, Robert. So the very last one then should be Tom. Are you there? There he is.
Hello. Hopefully you can hear me.
There you go.
Hi. So I'm Tom Edwards. I've just finished my third year doing digital electronics. So my project's looking at asset security, trying to track assets, and specifically we were looking at Tinsley Bridge. You can see on the right-hand side they have this measuring tool that's supposed to be used in this workplace, and they wanted to make sure that they were alerted if it left the workplace. So the progress that we've sort of made since the last time I spoke is that the beacon is now motion activated. So this improves the battery life quite dramatically, because it's only actually advertising when it's in motion. And then also we've developed the ESP32 base stations, and they're able to tell when the beacon is inside its zone. And then we're using Node-RED to trigger an email alert when it gets a LoRa message, and that can be cancelled if the beacon returns to the workplace. So it waits about 2 minutes after it gets the LoRa message, and then we'll send out an email alert to management. So Alex Kelly very kindly let me go to Tinsley Bridge and showed me around, and we had a go at deploying the solution. And unfortunately, we ran into some issues quite early on with getting communication with the gateway, but hopefully we'll be able to figure these out, and we'll be able to, in the future, get this solution deployed. So we ran into some problems with the Bluetooth firmware as well for the ESP32s. It's not very optimized, which means that the battery life for the ESP32 base stations is much shorter than it should be. It's only sort of, they'll last weeks instead of months, which has obviously maintenance issues. So hopefully we'll be able to work around those. And also a limitation of sort of the system that we've developed is that the zones need to be fairly spread out, because otherwise there's issues with knowing exactly where the Bluetooth beacon is and which zone it's in. So they need to be sort of at least 3 or 4 meters apart, sort of have clarity of where the device is. Thanks for listening.
Cool, thanks for that, guys. Yeah, so I think you last three have got away without any difficult specific questions. I mean, various general questions about insights. Of course, your insights have been a bit limited because none of you have been allowed into the factories and the buildings. So a lot of these students, they've been designing these cool systems and these cool analytic techniques, and it's really, when the world opens up again, we'll find out what they've discovered, certainly for some of those ones at Tinsley Bridge. I'm sure Alex is going to have them all applied. So with that said, as I said at the beginning, the computers video on GitHub. I promised to tidy it up a bit after they finish submitting, and then I'm sure we can circulate the link to that. Mark, you want to follow up from there?
Yeah, thank you, Ramsey, and thank you to all the students. And first of all, thank you for all of their presentations, both on this meetup and July's. And it's great to see the progress they've made, despite, as I said, the hurdles they've been facing with regards to access, equipment, etc. And it'd be really interesting to get an update further down track of how these things have panned out. I think also we should thank the likes of Tinsley Bridge, AMRC, etc., who've facilitated and assisted and supported these students in this project. It's very grateful, and of course all the mentors that have been involved. So yeah, well done to everybody in their involvement in this. I think it's been a really worthwhile project. And we're certainly, from Ioetec's point of view, looking at trying to assist in any way that we can as far as trying to get some of these devices into the real world and collecting real data. So thanks for that, Ramsey, and to all the interns. I'll hand you over now to my colleague, Mike Fawkes, who's the Ioetec CTO and designer of Ioetec's platform, but he's going to talk specifically about the future issues that we'll be facing with regards to quantum computing and the threat to IoT. So over to you, Mike.
Thanks, Mark. Just before I start, just again, congratulations to all of the interns. Great job, great presentations. Well done, everybody. So I'm Mike Fawkes, CTO of Ioetec. My topic today is the quantum threat to IoT. Although, to be honest, this is a quantum threat to the internet as a whole. At some point, quantum computers will be able to break all of the encryption we use to see data on the internet. And in addition, all of those countries and organizations which are currently storing and stockpiling data will be able to retrospectively decrypt that information. And it's not just me saying that. Estimates for a usable quantum computer vary from 2 to 12 years, but governments in the UK, the USA and China are all sponsoring development. Major companies like Intel, Google and IBM are working on quantum supremacy solutions, and there is real concern being expressed by organizations such as the NCSC in the UK, DARPA and NSA in the US, and international standard bodies like NIST about the effect that this will have on encryption. What I'm going to talk about today is why quantum is a threat to cybersecurity and IoT and what needs to be done about it. I'm not going to go into the technical detail of what a quantum computer is and how it works. I'm not a quantum expert, and to be honest, I don't quite understand it. I'm not alone. Einstein said that if quantum mechanics is correct, then it signifies the end of physics as a science. And the quote, "I think I can safely say that nobody understands quantum mechanics," is from the world's leading experts, Richard Feynman. So it's a tricky subject. But I do know a bit about the problem that quantum will have on cybersecurity. And I'll go to through this in more detail in a minute. But the issue is that quantum computers can solve multiple calculations simultaneously rather than one at a time. So what's the problem? Well, when we secure data on the internet, we need to encrypt it. And we do this using AES, the Advanced Encryption Standard. This works by both parties having a shared secret key and applying that key to the data to make it unreadable. The key can be varying lengths, but the most common is 256 bits. And that's what everybody calls military-grade encryption. Because it's an algorithmic process, data is not only changed, but it is swapped around. And it cannot be decrypted unless you know the secret key. It's estimated that it would take 1 billion computers powered by 150 nuclear power plants, the age of the universe, to mount a brute force attack on AES. And because it's an algorithm rather than just a set of calculations, it is quantum proof. So far, so good. But if you're going to have a shared key, then you have to exchange that information between the two parties. And that means you need to know who they are. What we use to do this is transport layer security, or TLS. And that is how the internet is secured and what gives you the padlock on an HTTPS site. TLS comprises a method of secretly exchanging keys between two parties and using a valid certificate to check the identity of the person you're talking to. The secret exchange of keys is done using a process called asymmetric encryption. This is where there are two keys. One is used to encrypt the data and a different key is used to decrypt it. This process is not reversible, so the encrypt key can be made public and only the decrypt key needs to be kept private. Using this method, anyone can send you a secret message by using a public key to encrypt, and only you can decrypt it using your private key. As a byproduct of this, you can swap the keys. So if you encrypt using your private key, then you have in effect signed the data, because the recipient can verify that it's your signature by decrypting using a public key. Public keys are encrypted using a certificate, and your identity is verified by the certificate authority. You put all of this together, and we have a method. Sorry, I've been not been advancing my slides, I don't think. So, sorry about that. Put all of this together, and you have a method of exchanging secret information between the two authenticated parties. So we have a secure internet that we all use every day. But along comes quantum. Asymmetric encryption with public and private keys relies on difficult mathematical problems to match the keys. As an example, RSA, one of the methods used in TLS, is on multiplying two huge prime numbers together. The multiplication is quite easy for a computer, but there's no easy way of reversing this and factorizing a prime number into its two component primes. As an example, if I asked you to multiply 47 by 37, then you could use a calculator to quickly get an answer of 1739. But what if I asked you to calculate the two primes that make up the number 1653? Which I've mistyped there, I apologize. It's going to take you a long time. And that's just a small number. The numbers we use for internet encryption are over 600 digits long. Anyway, back to quantum computers. Conventional computers use bits which can be a 0 or a 1. Quantum computers use qubits, which can be both a 0 and a 1 at the same time. So conventional computers can hold one 64-bit value in 64 bits. A quantum computer can hold 2 to the power 64 possible values. which is over 18 million trillion different values. This means that a quantum computer can solve problems all at once, rather than just one at a time, and therefore vastly speed up some mathematical processes, like asymmetric encryption. So what do I mean by vastly speed up? Well, to break RSA 248-bit keys would take a conventional computer 30 trillion years. It's estimated that a quantum computer with 5,000 stable qubits would break it in about 10 seconds. We're not there yet, but Google announced a 53 qubit quantum machine last year, so it is on its way. Anyway, now we have a real problem. The AES encryption we may use is but we no longer have a secure way of exchanging keys and checking identity. Incidentally, the same problem occurs with things like cryptocurrencies. The blockchain is still okay because, like AES, hashing is still secure, but the signatures to identify the senders use asymmetric encryption, so are now vulnerable, and you'll be able to retrospectively get the transaction identity for all transactions. There is a solution, but unfortunately it's not ready yet. Sometime in the future, we will have the quantum internet. Keys will be generated by quantum random number generators, which will be able to generate enough keys to secure all data with a different key. This is theoretic secure encryption, which at last is totally secure. The keys will be distributed by quantum key distribution systems, which worked on entangled light protons. These have magical properties, which means that, like qubits, they do not have a binary 0 or 1 value, they have both values. But because they only become one or the other when they are observed, that gives you the ability to be able to observe if your keys have been intercepted, and you can therefore discard them. I know all this sounds a bit made up, but quantum entanglement has been demonstrated in experiments, and if you're interested, there are some good documented results on YouTube. However, this is the future. At the moment, quantum random number generators are not fast enough to generate enough keys, and quantum key distribution needs fiber optic links, expensive equipment, only works point to point between two parties, and has a distance limitation of a couple of 100 kilometers. As an interim solution, we have post-quantum encryption. These are algorithms which are theoretically quantum proof, but there's nothing to say that a method of breaking them will not be found in the future, particularly when we have quantum computers to help with the analysis. We will need an international standard agreed by everyone. But despite the urgency, NIST has already been discussing this for 4 years, and announced in May this year that they had narrowed the field down to a short list of 15 solutions. But as we now enter a 2-year consultation period, it's not happening just yet. So is this a real threat or just a presentation? Well, the NCSC and the NSA state on their websites that they expect a quantum computer capable of breaking encryption to be commercially available in less than 10 years. They also state that military data, as an example, needs to be kept secure for at least 20 years. So yes, there is a clear threat. Many companies, Ioetec included, are working on both immediate and long-term solutions to this problem. And I hope that I'll have the opportunity to come back early next year and talk to you about some of these solutions. Meantime, thank you for your time, and does anyone have any questions?
Thanks, Mike. It's quantum has got a lot of comments on the chat there. There's no specific questions I can see to ask you, Mike. But yeah, when we are tackling this, hopefully in the early part of next year, from our perspective, I'm sure you will be able to enlighten them with a little bit more what we're doing. I've got a quick question from Phil here saying, how would a small IoT device handle requirements like processing needs?
Yeah, thanks, Phil. I thought I could rely on someone to ask that when you look at the expense of doing quantum. What you've got to look at with any device is where the threat is and what resources you have to be able to solve that threat. So within an environment which is where you've normally got your local communication, it's not as much a threat as if you're getting things externally. So the encryption itself isn't a problem. What we have to look at for IoT devices is other methods of being able to do the verification of the identity, other than obviously using quantum. But quantum would still then be used to be able to transmit from site to site. As the costs come down and new techniques are improved, then obviously the cost will come down significantly. It's never going to be a solution for a temperature sensor, but if you're looking at securing a nuclear power station, or you're looking at critical national infrastructure, then you have to be able to secure end to end. And we're now moving to the point where the threat becomes on the internet side rather than the device side within a closed environment.
Thanks, Mike. One from Robert there. Will quantum computing always only be very large things in the hands of the likes of Google, or do you think it will eventually feed down to, will we be seeing quantum computers on our desks at home?
It's difficult to know. I mean, the rate at which developments are happening is starting now to follow, kind of other expansions of computing. The big players are all doing it, but I did read recently that half of the world's investment in quantum is happening in China. So the answer to that is we don't know. But yes, I mean, Phil's just posted a comment about quantum in the cloud. That certainly will be one of the ways that we can start using it. Although of course you have to secure your link to the cloud for it to be effective. So there's an interesting quandary there, I think. Okay.
That's great. Thanks, Mike. And in fact, if I can thank, is there some of the other 5,000? Do you want to respond to David's questions there just before I wrap up?
Yeah, so Google announced last year that they got 50. They need 100 times that to have a fully quantum computer. But as I said, the number of stable qubits that can be generated is increasing quite rapidly now, kind of year on year as the science improves.
Great. Well, thanks for that, Mike. It certainly garnered a lot of comments in the chat there, and as I say, hopefully we'll be able to come back in the future, and when we're talking about another one in our series of cybersecurity, hopefully you'll be able to give us an update on that.
Yeah, I'll press on computers themselves when I figure out how they work.
So my thanks to Mike, also to Dr. Martin and Fabio Seravenga for their contributions. Taylor for heading that one up as well. So just finishing up now on our shout out, just closing the session down. If anybody's got any announcements they'd like to make, feel free to. My video is going bad. Is it mine? Hopefully, I'll just plough on in the hope that we can you at least get in my audio. Just the opportunity now for anybody to shout out and make any announcements relating to IoT, etc. I've got a few slides in a second, but maybe I can hand you over to Tracy at DMC. Tracy?
Don't worry, Mark.
Hi. Go ahead, Kerry.
I can just say what Tracy was going to mention, and it's the exciting news that the next cohort of IoT Tribe is coming to the DMC, I think from November. Might just want to check that, but I'm pretty sure from later in the autumn. And the topic is going to be about smart buildings. And so it's another industrial IoT application in terms of the cohort theme, and essentially it's really exciting that this will be now the third cohort, and it's perhaps worth saying that we're seeing the former alumni really do incredibly exciting things, the likes of Ioetec. And Mark, I don't know if you want to do a shout out about your recent success, but also the likes of Proxy Group, who use RFID solutions in various guises. For example, at Doncaster Airport, where they've been taking luggage to help with the flow through. But given the situation with air travel, they've pivoted recently and have just won a big contract with the NHS to help with RFID tracking of assets. So it's very exciting that we've got this third cohort, and I think we're going to be trying to link up in various ways between the Sheffield IoT Meetup and the Tribe in the coming months. So yeah, watch this space. Thanks.
I've managed to unmute myself now. Can I just add a couple of things?
Oh yeah, go Tracy.
Thank you, Kerry, for that very, very eloquent description of what we're doing. But yeah, so Barnsley is, we're really, really pleased to be able to commit to and invest in a third cohort of IoT Tribe. As Kerry said, the programme will be a little bit different this time due to COVID. So majority of the programme will actually be delivered online, with only sort of some elements of it actually being delivered on site. The timetable will be we're promoting and recruiting to the programme between now and kind of November time, and there'll be some design studios in December, we believe, and what that gives us is a chance to work with more startups than perhaps we have done in previous cohorts. So we'll be doing these wider design studios to really get a range of different startups involved, and then that will filter down into a tighter cohort for the full programme, which will run January through to March in 2021. But it's also worth mentioning that there is a huge scale-up planned of accelerator type activity, not just for IoT, but for all technology-led companies. Subject to sign off, the Team SY project will hopefully be up and running along a similar timeline. So it's going to be part of a huge amount of stuff that's happening at regional level. And it's great to have kind of have got this far with it actually, and to be sharing it with you all. So fingers crossed for another successful cohort.
Great, thanks Tracy. And yeah, as former alumni to IoT Tribe, I can wholeheartedly support and encourage anybody who's got some interest in the programme to most certainly make the application. And certainly Tracy, just let us know and we'll publicise, promote it as best as we possibly can, both through the IoT Meetup and through all our various networks. Geraint has published a link there as well for follow-ons from the pitching projects. So KTP Best of Best Awards 2020 that needs to be registered for the register on Seedent, and that's for the 9th of September. So just refer to the chat for the link there. Also, Stephen has saying that they're doing, Stephen Elliott is saying we're doing a project using Bluetooth low energy beacons for occupancy management in museums. If there's anybody in this community that can talk about it, please contact him at llama.digital.co.uk. His email's there. And we're happy to pass that on. Just a quick shout out from myself. If I can move to the next slide. Yes, here we go quickly then. Just to promote a couple of other activities, the IoT Security Foundation have their virtual conference. It's a 4-day event, all virtual, and you'll need a registrar. There's a link just there at the iotsfconference.com. I attended last year's one, which was in person, and it was a great event, really interesting subject matter, and the IoT Security Foundation, I would suggest, sort of world leaders in setting the standards and rolling out the roadmap for security for IoT, and they really are leaders in this field and influencing both government policy as well as what's happening on the continent in Europe. So definitely worth, if you have the time to participate in that or join that, worthwhile. They also have a number of webinars that are forthcoming, all free, which relate to the three top security provisions that are being required by the new ETSI standards for our IoT consumer devices, for default passwords, updated software and vulnerability reports. So again, if you go to the IT Security Foundation site, you'll be able to register for those webinars. There's a series of them, actually started yesterday, but they're running all the way through for the next couple of months. Digital Catapult, we've got a 5G bunch of webinars. Again, there's the link for you in the bottom left-hand side. It's 5G week coming up in the beginning of September, and there's a lot of activity online with regards to that. If 5G is an area that you're interested in, and Digital Catapult also, I think I've skipped a slide there. I've lost a slide somewhere. With them, I'll just mention Lorca Live. Again, we're alumni of Lorca. They've got a live, again, free webinar over between the 14th and 18th of September. This is all security and cyber related. Fascinating event. Again, go to Lorca Live at lorca.co.uk for more details and registration. They're, again, a free event. There's the Digital Catapult one. So they're running a IoT discovery program. It's to connect large businesses with people who are providing OT solutions. So again, there's the link there. These will all be available online when we publicise this particular event on the Pitch-In website. There is a accelerator that's come up between the UK and the Chinese-British Business Council. It has to be registered by tomorrow, so if you're interested in this, don't delay, sit up late and get onto that link there at the cbbc.org site for the Tech Accelerator to support IoT development, so in front of investors and clients and partners in Shenzhen. And there's the Sheffield Digital current calendar over the next month or so. You can get that at the Sheffield.digital site as well, so give you a few of the ideas of what's happening. And then I think just finally, just to before you all go, our next number 8 meetup will be for Thursday, the 1st of October, and we'll be a year old on that day. It'll be our year's anniversary, just beyond the eve of our first year's anniversary as an IoT meetup. We'll give details through the meetup site and through the various links that we have. We'll be looking again at Smart City. It's been almost a year since we visited this. There's been a lot going on. From our perspective, and thanks, Carrie, for the prompt, Ioetec were very pleased to have won an Innovate grant with a consortium called Synergia, which is a Toshiba-led consortium where we are looking at providing a smart city platform and the security for this with the University of Bristol, Smartia, another one of our IoT Tribe alumni, and a couple of other companies. But we'll be presenting a little bit about what we're doing, or getting somebody from Synergia to speak about that. And there's a couple of other projects that are going on as well. So we're looking at Smart City up on the 1st of October, and I'll let you know through the usual routes, channels, in Meetup, etc. So I think that's us. Just a quick one there from Tracy, opening DMC2 in Barnsley next month, co-working space and a new maker lab. So again, go to the Barnsley dmc.co.uk site. And I'd just like to thank everybody for coming along today. Thanks for sticking with it. We're bang on at 7:15. Thank you so much for for your attendance today and for all of the presenters, and we look forward to seeing you in a month's time. Thanks. Good evening, everybody.